This is the first attempt at concurrency that we had in this course, where we created a runnable and then started new threads to have the prime number calculation happen in a separate thread and then print the value right there in the thread. There was no handoff back to the main thread. So we're going to enhance this by having this separate thread be a callable instead of a runnable, and have that callable return the prime number value instead of just printing it. And we're going to have our application print out the value. All right, so what I'm going to do is I'm going to copy this thing and create a new class. Now I'm going to paste this here, and we're going to modify what we've got here. All right, so this is our code as is. Nothing has changed here, right? It's basically what we had before, but now I'm going to enhance this to make it a callable. Okay, so the first thing I'm going to do is, instead of a runnable, I'm going to make this a callable. And now, since this is a callable, let me import this. This is a callable. I need to implement the methods here. So I'm going to copy this. Let me actually remove this and do this again. I don't know why I'm reusing the same thing. I'm going to create a callable of integer, right? What do we want this callable to return? We want it to return the prime number. I'm going to use an integer. So I'm going to say callable of integer. C equals new callable, and now what I get is a call method which throws an exception and also it returns an integer. Now what I need to return here is this guy, prime number util dot calculate prime of n. Okay, so I'm basically passing this n over here and having it calculate. So similar to what we did earlier, right? We had a runnable, but now instead of just calculating and printing it, I'm just returning the prime number. Okay, that's fair, but now the thread doesn't work anymore because now I have a callable. I cannot pass it to thread. What I'm going to do instead is create an executor service. I'm going to create an executor service. Executor service equals, you know the drill now, executors dot, I'm going to use a new cached thread pool so that I don't have to worry about running out of threads. So it basically creates as many threads as needed. It's going to do the right thing, so I'm happy with that. And now I need to pass this callable to this executor service. I need to submit it, not execute. All right, so I'm going to do executor service dot submit, and I pass the callable. But now what I get back is a future object, right? I need to print the prime number in this main application thread now. I cannot have it, I've removed it from the call method, right? It's just returning a value. So I need to have it printed over here. So what I'm going to do is, I am not going to, well, one thing I can do is do something like this, right? I'm going to get the future object. And then I'm going to do a prime number future. Okay, so what this is going to contain is, this is the box which will eventually contain the return of this prime number calculation. Now I can peek into the box right away and I can say prime number future dot get, and then I do a sysout of prime number future dot get, and I basically say number is, or maybe I just use the nth prime number is, and then I do a prime number future dot get, and now I throws an interrupted exception. I am happy to have the main method throw an interrupted exception. I don't want to catch it now, so I can technically do this. Now we know what happens if I do this, right? This is basically going to wait. Now if I were to do like 10,000 or the 100,000th prime number, this returns a box and say, hey, I'm going to fill it later, but you're like, no, I don't want it later, I want it now. So what is this going to do? This is going to block. Okay, so let me show you. I'm going to run this and enter a small value. Well, that is going to return fine. Well, it's not technically not fine because this is still blocking, but you don't feel it blocking because it's a small value. But now if I were to enter a big number, well, I cannot do anything else. It's not even going to the next line here. You see this? This should ideally have gone to the next iteration of the while loop, but it's not even going to the next iteration because it's stuck in this line. You're saying, I want the contents of this box now, and the future object is saying, well, then you need to wait because it's not done yet. All right, this is a problem. So here's what I'm going to do. What what I'm going to do is I'm going to hold on to this future in an array list. Okay, I'm going to hold on to this in an array list, and then I'm going to just print it out by constantly checking the values. Okay, I'm going to constantly check if this future is done, and then I'm going to print it out. So here's how I'll do it. I'm going to create an array list of future objects. List of future of string. Okay, so I'm going to hold on to future of string in an array list. Okay, futures. Let me get the syntax right here. This is list of future of string. Futures equals new array list. Okay, and every time I get a future object, I'm not going to say, hey, get me the value right away. I am going to hold on to this in this list. I'm going to say futures dot add of this prime number future. Well, this is a integer, I'm sorry. Right, we're looking at a futures of integer. Okay, so I'm going to hold on to this in a list, and I'm not going to do a get right away. All right, what I'm going to do instead is look at all the future objects to see if any of them are done. If they're done, I'm going to print and remove them, and I'm going to do that each iteration. Okay, so I'm going to do futures dot for each future object. I am going to look at if any of that futures are ready. Okay, so I'm going to do f dot. So future is a future object. I have this method called isDone, which tells me if this future object is done or not. Now I don't want to do a dot get here, because in that case it's just going to block it, which is not what I want. So what I'm going to do is I'm going to check, hey, is this future object done? I'm asking the future object, the box, hey, is there something inside the box? Okay, if it is done, then I'm going to do a sysout future dot get, and then after that I'm going to do a futures dot remove of this particular future object. Right, I don't need to hold on to that anymore because I've already printed the value. And since I'm doing a remove, I cannot use a for each. There's going to be a problem because there's going to throw a concurrent modification exception if I remove while doing a for each. I'm just going to use an iterator. All right, so I cannot use a for each and modify the underlying array, because that's going to mess it up, and even a for loop messes it up. So I'm just going to do futures dot iterator, so that I get an iterator to iterate over and then remove. And I'm going to do a iterator and then while iterator dot as next, I'm going to loop and do it that way instead of using a for each loop or a lambda. So I'm going to have a future of, I don't know why I keep typing string, future integer equals iterator dot next, and then I'm going to do a iterator dot remove so that it doesn't mess with my looping. Okay, so essentially what I'm doing here is looping through all the futures, right, by doing iterator.next, and for each iteration, what am I doing? I'm getting that value and I'm checking if it's done. If it's done, I'm going to print it and then remove it. Okay, so now if I run this thing, what it should do is pretty much like what we did before, but you're going to get the prime number only on the next iteration of something. Okay, so if I were to enter 2, it would have calculated it, put it in the future, but it prints it only on the next iteration. In that same iteration, this would have run, but it wouldn't have been ready. So if I were to enter another number, I'm going to get the value of the second prime number now. All right, you see this? I get the value of, actually I get the value of both, which is interesting. All right, so if I were to enter a bigger number, I don't have the value now, but if I were to enter a smaller number, I'm going to get the value of both. It just so happens that this got completed in the same iteration. Otherwise, it would print in the next iteration. All right. So I know this is not ideal, but it's a good use case to demonstrate how you can use callables to have your tasks run in a different thread and kind of hand it back to the main application thread. Now your main application thread is doing this. You can of course do this a bunch of different ways. You know, this is probably not a good place to put it. What you could do is have all these numbers input, and then when the user enters 0, you can have all of them print out the value. Okay, so that's another way to do this. For example, I can take this iterator out and then say, while this is happening, I'm just adding on to the futures, and it's going to calculate in the meantime, right? It's not going to wait around for you. But then once you're out of the loop, then it is going to loop through all the futures, and if any one of them are done, then it is going to print them out. Okay, so let me run this. Okay, so I want the second prime number, the 5th prime number, the 20th prime number, 4th prime number, and now when I press 0, now I have all these futures, right? They're all done, hopefully at this point. And now if I were to press 0, it is going to print all of those because it's getting the value from the futures. If it isn't ready yet, it's going to wait, complete it, and then print out the value and then move on. Okay, so this is using futures and callables in an actual application for handing off calculation to another thread and then getting the value back.